Okay, this video is going to do part 2 of the logs and their graphs. We're going to focus today on the graphs of logs and ln functions. So if we compare the graphs of logs to exponential, you'll see that they're inverses of each other. Everything that's true about the x values of your exponential function are true about your y values of logs. So we can choose to, if I wanted to graph, let's say, log base 2 of x, I can actually graph 2 to the x, the way we've been doing it by plugging in -2, -1, 0, 1, and 2 like that. And then literally switch our x and y values. So for every value of x, we would switch it so it becomes the y value. That's one way to do it. The way that I want you to do it that I think is easier is we will just take that log and we will plug in for the y values. So you'll take your log expression, you'll convert it into exponential, and then the exponent will be the y, will be in the exponent, and then that's where you'll plug your values in. So the other things that are a big difference is that on the exponential functions, we had a horizontal asymptote. With logs, we have a vertical asymptote. So the vertical asymptote here, which would be an x equals 0, shifts with your horizontal change. So where the exponential function had a horizontal asymptote and it moved with a vertical shift, these are going to move with a horizontal shift. So we plug in for those are the biggest difference. We plug in for the y values, and then there is a vertical asymptote that shifts from left to right when there's a horizontal shift, and that's the opposite of the exponential functions. So if we look here, it says graph the log function. So we're going to set up our t-chart similar to what we did for exponential, except we are plugging in to the y this time. So I'm going to now take this equation, I'm going to convert it into exponential. 2 picks up the y, and I'd get 2 to the y equals x, and then I'm going to plug in my values of y. So 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first, and 2 to the second. 2 to the -2 would be 1 over 2 squared, which is 1/4. 2 to the -1 would be 1 over 2. 2 to the 0 would be 1. 2 to the first would be 2. And 2 to the second would be 4. Now when I go to put this on my x and y coordinate plane, pay attention to these points. The x is the 1/4. 1/4 and -2 would be here. 1/2 -1 would be here. 1, 0 is going to be here. 2, 1 here, and 4, 2 here. And we said there's a vertical asymptote at x equals 0. So my graph is going to look just like this. The arrows point in either direction. It's going to get as close to without touching that vertical asymptote as it possibly can. So if we were to focus on the things that we had been asking about with the exponential functions, now our domain is restricted. It goes from 0 without touching 0 to positive infinity because that's left to right. My range is not restricted. It would be all real numbers or negative infinity to positive infinity. My vertical asymptote is at x equals 0, and my x-intercept is what I would find from the middle point on my t-chart or from my graph would be 1, 0. So the reverse of the x and y's for the exponential functions that we were used to. Let's do it again. So this time, graph the log function. This base, remember, is 10. So this is y equals log base 10 of x. 10 comes over and picks up the y, and I'd get 10 to the y equals x. I'm just going to do -1, 0, and 1 this time. 10 to the -1 is 1/10. 10 to the 0 is 1, and 10 to the first is 10. Anything bigger or smaller is going to be hard to plot, and bigger is going to go off my graph. So 1/10 and -1, 1, 0, and 10, 1. Vertical asymptote is at 0, 0 because there's no horizontal shift. The horizontal shift is going to be in parentheses with the x. You'll see that in a minute. My graph looks like this. My domain would be, again, 0 to positive infinity, range, all real numbers, vertical asymptote at x equals 0, and x-intercept at 1, 0. All right, now looking at, we're on example 27. So now we're going to graph, but look at what's happening here. Think about all of the other transformations. Anytime that something's added or subtracted inside the parentheses, this causes a horizontal shift. So because this is going to get shifted when we go to plot our points, you're going to shift your your vertical asymptote as well. So if we didn't catch it and we had to plot our points, we would still get x and y. We would do -1, 0, and 1. The base here is 10, so 10 is going to come over and pick up the y. 10 to the y would equal x minus 1, and then I would move the 1 on the side with the 10. So when I plug in, I'm plugging in there. And I would do 10 to the -1 plus 1, and then 10 to the 0 plus 1, and then 10 to the first plus 1. So this would be 1/10 plus 1, or plus 1, or 1 and 1/10. This would be 1 plus 1, or 2. And this would be 10 plus 1, or 11. So now when I go to put those on the graph, 1 and 1/10 and -1 is here. 2, 0 is here. And then 11, 1 is just off my graph, off here to the side. But what's easier to draw is knowing that my horizontal asymptote would shift to the right one. So I can find that by setting this equal to 0. I'd get x equals 1. That's my horizontal asymptote. Or remembering that it's at 0 and a shift in here with a minus would be a right one. That also shifts it to the right one. So now I know I have a vertical asymptote here. Oh, I said horizontal before. A vertical asymptote there. I can connect these points to better make my graph after I plot that asymptote. So it will naturally happen by plugging in the points. You won't get anything to the left of that vertical asymptote, but you're going to be asked for it. So vertical asymptote at x equals 1. Domain just got shifted to the right one. So it's 1 positive infinity, range, all real numbers, x-intercept, still the middle of my graph, or my t-chart, which is 2, 0. All right, one more example like that. This time the plus 2 is separated out. It's not inside the parentheses. So this is the same thing as saying log of x plus 2. This is a vertical shift up 2. Doesn't impact my vertical asymptote. So my vertical asymptote is still at x equals 0. I'm going to plug in my points. -1, 0, and 1. This time, before I can convert it, before you can get that log on the side by itself, or before you can convert it, you have to get the log on the side by itself. So this is log base 10 again, but I have to move this 2 before I can convert it to exponential. So I'm going to subtract the 2, and I get y minus 2 equals log base 10 of x. Then the 10 picks up the whole expression there. So 10 picks up y minus 2. And when I plug in, I'm plugging into that expression. So 10 to the -1 minus 2, 10 to the 0 minus 2, and 10 to the 1 minus 2. Here I get 10 to the -3rd, which is 1 over 100. No, 1,000, sorry. This would be 10 to the -2, which is 1 over 100. And this is 10 to the -1, which is 1/10. So here's the hard part about this. When there's a shift like this, these points are all going to be super close together. So 1 in 100th and -1 is like there, or 1 in 1,000th. And then it would be right here for 1/100th 0. And then 1/10th 1 is still so close. Like even that is way too far to the right-hand side. But I do know that there's still a vertical asymptote here. So eventually my curve is coming up, and eventually it has to turn to the right, but it hasn't happened yet. If you want to plug in an additional point, like perhaps 2 for that y, you can get 10 to the 2 minus 2, 10 to the 0, which is 1. Then at least I have 1, 2 as a point. Keep going to the right, it would be 3, 10 to the 3 minus 2, 10 to the first, which is 10, and there's where it really starts to curve. 10, 3, 1, 2, 3 would be that coordinate point. So knowing that the vertical asymptote is there is enough to start your graph, but if you need the additional points to see what's happening to it, you can always plug in some more. So vertical asymptote x equals 0, domain 0 to positive infinity, range all real numbers, x-intercept 1/10. Oh, I circled the wrong one, sorry. Would be 1/100th and 0. Okay, so now we're going to graph the natural logs. Remember that the natural log is that ln is the same thing as log base e. So if I see f of x equals ln of x, I can convert this to y equals log base e of x, and then change it so it's exponential, and then everything else we're going to do the same way. We're going to plug in for y. Okay, so it's an ln. It has a horizontal shift here, so my vertical asymptote just shifted to the right 2, so this is at x equals 2. I'm going to take and make my t-chart, -1, 0, and 1. I'm going to change this so it's y equals log base e of x minus 2. E is going to come over and pick up the y, and then I'm going to add the 2. So e to the y plus 2 equals x. And now we're plugging in for y. E to the -1 plus 2, e to the 0 plus 2, and e to the first plus 2. This we need calculators for. Not all of it, actually. But e to the -1, you're going to find e above that ln button. E to the -1 is 0.367. So I'm going to round that to 0.4, and then I'm going to add 2. So 2.4. E to the 0, we don't need the calculator for. That's 1. 1 plus 2 would be 3. And e to the first, we said to estimate is 2.7 plus 2 would be 4.7. Then I go to my graph. My vertical asymptote is at 2. And then I've got a coordinate point at 2.4, -1, 3, 0, 4.7, 1. This says find domain, so it shifted to the right 2, which means the domain would be 2 to positive infinity. Range all real numbers. We found the vertical asymptote. X-intercept would be 3, 0. Okay, let's graphing example. Again, an ln. Again, a horizontal shift. So this time it's 2 minus x, but if I set that equal to 0, I'd end up with x equals 2. So my vertical asymptote is still at x equals 2, but you're going to see what happens with these points is a flip because of the negative on the x. So I'm still going to plug in the same values, -1, 0, and 1. Y would equal log base e of 2 minus x. E comes over, picks up the y. I can subtract the 2. E to the y minus 2 equals -x. But then I've got to multiply by -1. So either way, I'm changing these signs. Negative e to the y plus 2 would equal x. Or 2 minus e to the y equals x. Plug in for the y. So 2 minus e to the -1, 2 minus e to the 0, and 2 minus e to the first. That e to the -1 was 0.4 again, so 2 minus 0.4 is 1.6. E to the 0 is 1, so that's 1. And e to the first is 2.7, so -0.7. Go to plot these points, you get 1.6 and -1, 1, 0, and -0.71. So instead of my curve pointing up to the right like it should, there's a flip on my x because the x gets the negative, which means my graph is going to turn and face that way. If you were unsure about your graph, you can always graph this on your graphing calculator. So I went to the y equals, that's on the second one, doesn't matter. And the above, or actually below, the e to the x is the ln button. I did ln of 2 minus x, and then if I hit graph here, it cuts off because there's a restriction on those points there. It's going to hit that vertical asymptote, and we won't see the vertical asymptote, but you will see that curve happen to mock what we just found on by plotting those points. So you can always use your graphing utility again to check those. The homework for these questions does not give you the t-chart like it did with the exponential functions. So you should be able to pick these points each time, and you're going to want to graph these by hand. And then for the ones that select the graph, you're going to make sure you select the graph. So in addition to the graphs, you're going to see the one-to-one property in tonight's notes. So we did it with the exponential functions. Like if we had 3 to the x equals 3 to the second, then we set these equal to each other. It's the same process for the log. So if you have log of the same base, they have to have the same base here, then you ignore the logs and you just set what's next to it equal to each other. So if it had said log of x plus 2 equals log of 5, I would set these two equal to each other. X plus 2 would equal 5, and x would equal 3. You're going to see ones with some exponents, like if you had log of x squared and then log of 9, this x squared would equal 9, and you would get x equals plus and minus the square root of 9, which would be plus and minus 3. So you're going to see a couple of questions with that one-to-one property. That's how you do it. Just set it up, set them equal to each other, and then you're going to graph. And again, make sure you are graphing by hand and then select. So show your t-chart and then select the graph if it's multiple choice. And take the time now to submit these notes. To today's assignment so you can get credit for your classwork. Have a great day, guys. I'll see you soon.